Okay, today guys, we'll be seeing integration. Okay, so I've taken some choice of questions, which models are important for the exam and all. Okay, fine. So let us see the first model. Now this, for every question, more or less, like there will be a general form. I will write the general form in the side. Okay, so that even if there is a change in the question, you can follow it. Okay. Now this question is pretty straightforward only. Very simple. Here, if you see everywhere in the denominator, there is x square. And in the numerator, you can see x dx. So this is pretty straightforward. You can take x square as t, which means 2x dx will be dt. So this will be integral dt by 2, half I will write outside, by t square plus t plus 1. Okay. Then you know how to write perfect square. Dt by denominator will be t plus half whole square plus 3 by 4. So it looks like integral dx by x square plus a square. No? And it is 1 by a tan inverse x by a. The answer. So just do that 1 by 2 times. So 1 by a is root 3 by 2. Tan inverse x by a. Instead of x, what is there? T plus half by a. A is root 3 by 2. Okay. So this will be the answer. So you know, right, in integration, integral f of x dx, if it is some capital F of x plus c, then integral f of, instead of x, some linear term is there, at plus b dt. Then it will be f of at plus b divided by coefficient of that linear term plus c. Okay. So yeah, let us see the next question. Yeah, this is also one important model. This model is something like this. You see, if you have an integral of the form x plus a, some power is there m, and to x plus b, some power is there m, and I'm writing both in the denominators. Okay. So if someone has given something in numerator x plus 2 power 1 by 3, bring it to denominator like by x plus 2 power minus 1 by 3. Okay. If you bring it, you will have some powers, na, m and n. So if m plus n is equals to 2, that is how this model questions will be. Okay. Then what you do is either you take x plus a common or x plus b common from the denominator. So either take, okay, I told x plus a, na, x plus a whole square or x plus b whole square common from denominator. Okay, let us see how to do it. Here, integral dx by, this is x minus 1 power 3 by 4 into x plus 2 power 5 by 4. Now, what is the sum of these two powers? 3 by 4 plus 5 by 4, that is 2. So then what you do is take any one, like let us take x plus 2 whole square common from the denominator. So if I take, so x plus 2 whole square, if I take common, already 5 by 4 is there. So how much more I have to take common? 3 by 4. So it will become x minus 1 by x plus 2 power 3 by 4. Like this. Then one important point, derivative of, if you differentiate ax plus b by cx plus d, derivative of linear by linear, it will be ad minus bc by cx plus d whole square. AD minus BC is something which you come across in whole of determinants, correct? So it will be easy to remember AD minus BC by. So this is very commonly occurring derivatives. Now, derivative of 3x plus 5 by 2x minus 1 is there. AD minus BC minus 3 minus 10 divided by 2x minus 1 whole square. Okay. So Here what you do is, in this question, take x minus 1 by x plus 2. If you take it as t, then its derivative AD minus BC, 2 minus of minus 1 by x plus 2 whole square dx will be dt. That is, dx by x plus 2 whole square will be dt by 3. So now where do you see dx by x plus 2 whole square? Here. So that will be dt by 3. So I'll write it as integral will be 1 by 3 times integral dt by x minus 1 by x plus 2 whole power 3 by 4. That is t power 3 by 4 only. Now this can be integrated, right? 1 by 3 into integral t power minus 3 by 4 dt. X power n. Okay. Next. Now, yeah, this may be a simple question, but actually general rule I will tell you. In general, if you have some integral dx by, and the denominator can be written as x minus alpha into x minus beta. That is, the denominator is a quadratic whose roots are alpha and beta. Then this integration will be 1 by mod alpha minus beta, okay, into log of x minus alpha by x minus beta plus c. Now here, your alpha must be less than beta. Alpha must be the smaller root. So in the numerator, smaller root must be there. Sorry. Minus alpha is there, no? So then alpha must be more than beta. 1 second, guys. I'll just erase. Okay. Your numerator must be the larger root. Let us take one simple example. Integral dx by x square minus 1 is there. Now this is simply dx by x minus 1 into x minus x plus 1. So denominator has two roots. Na? Already you can identify it. The two roots are minus 1 and 1. So the answer will be 1 by difference between the roots. That is 2, positive difference. Log of mod will be there. Now x minus of larger root. What is the larger root? 1. What is the smaller root? Minus 1. So the answer is 1 by 2 times log of mod x minus 1 by x plus 1. This is the standard formula which you learn. Okay. Same way, like if you have integration dx of x square minus 3x plus 2, let's say, you can see clearly the roots of this are 1 and 2. So directly you can write the answer 1 by difference between the roots is 1 log of mod x minus the larger root is 2 na? And the smaller root is 1. This will be the answer. Okay. So, or if you have some complicated integral dx by x square plus x minus 1 is there. Now this discriminant is positive. And what is the difference between the roots? Square root of discriminant by mod a. Already we know that is square root of 5 divided by 1. So the answer will be 1 by difference between the roots is root 5 log of mod x minus the larger root. So first you should know the roots of that. Now what are the roots of x square plus x minus 1? Minus 1 plus minus root 5 by 2. So the larger root is minus 1 plus root 5 by 2. And the smaller root is minus 1 minus root 5 by 2. That's it. This will be the answer. Okay. So that is what you need to do from this question. That is what I want to actually, okay, discuss. Now here it is very easy. X square you take t. Then the next part will be dt by t square minus 1. Okay. Next. This is another, this is one model where, so you'll have a lot of model questions like this, like integral dx by sin x power m into cos x power n, cos power nx. If integration is of this form, where m plus n is even, then what you do is either take Let's say m plus n is even and that is k. So either take sine power kx or cos power kx common in the denominators. Okay. Any one of them you take common, you will get the solution. Let us see how. Okay. So here, powers if you add m plus n, that is 1 by 2 plus 7 by 2. How much it is? 4. Even. Na? Now, from the denominator, either you take sine power 4x or cos power 4x. Let's take cos power 4x common. So cos power 4x I am writing here. Then so already when you're taking cos power 4x common, one common term will be cos power 7 by 2. Remaining will be, so you will get sine power 1 by 2x is there. Now remaining cos power 1 by 2x I will write here. Now this minus this, it will be 7 by 2 only. No? It is balanced. So now this will be nothing but integral dx by, now this you see, tan x power 1 by 2 will come. And 1 by cos power 4x, you can write it as secant power 4x. Now you take tan x as t. Done. Then it means secant square x dx will be dt. So the numerator is secant square x dx. And one more secant square x is there. Secant square x is 1 plus tan square x, 1 plus t square, divided by t power 1 by 2. So it will be integral t power minus 1 by 2 plus t power 3 by 2 dt. You can solve this. No? Okay. Let us see the next question. Very simple. Now this model is something like this. Integration. In the numerator, for example, sin x minus cos x is there. Let's say. Okay. Dx. And in the denominator or numerator. So what I will do is, let me write something like this. Okay. Or in the denominator, you have a function of sin x into cos x and sin x plus cos x. That means you are seeing in the integration, it can be in the numerator also. That is f of sin x into cos x, comma sin x plus cos x. But what we are saying here, outside in dx, sin x minus cos x is there. Okay. So I'll tell you what does that mean. Okay. So here if you simplify, cot x is nothing but cos x by sin x. Tan x is sin x by cos x. Root 2 times sin x plus cos x is there. Dx. Now if you take LCM, it will be cos x minus sin x by root 2 is already there. And if you take LCM, 2 sin x into cos x will come in the denominator. And remaining is sin x plus cos x. Now if you see this integration, cos x minus sin x dx is there in the numerator. And what are there in the remaining parts? Sin x plus cos x is there, or sin x into cos x. So 2 is also there, so it's okay. Fine. Now, whenever you have such kind of thing, okay, very simple substitution. Obviously, sin x plus cos x derivative is cos x minus sin x. So sin x plus cos x only, you will take it as t. So such that if you differentiate, cos x minus sin x dx will be dt. Okay. But how will you write 2 sin x cos x? That is only the point here. If you square this one, sin square x a square plus b square plus 2ab, 2 sin x into cos x. That will be t square. So what is 2 sin x into cos x? That is t square minus 1. That's it. Substitute everything. Integral dt by root t square minus 1. And 1 is sin x plus cos x. That is t only. No? Now this is nothing but secant x derivative dt by t root t square minus 1. This is simply secant inverse t. No? And what is t? Sin x plus cos x. Okay. Yeah, let me just see. Any doubts, anyone? Okay. Next, integral dx by root 1 plus sin x. Okay. Now, whenever inside root like this, root 1 plus cos x is easy to do. So that's why what we do is simply instead of x, let us put substitution t or theta plus pi by 2. Then dx will be d theta. This will be integral d theta by root 1 plus sine. What is x substitution? Theta plus pi by 2. So it will be integral d theta by root 1 plus cos theta. And what is 1 plus cos theta? So 1 plus cos theta is 2 cos square theta by 2. Na? Okay, it is easy to do in cos, 1 plus cos, because that formula is like that. Square is there, root will get cancelled. So you'll get 1 by root 2 times integral d theta by cos theta by 2. Then next step is easy only. Integral secant theta by 2 d theta. You know what is secant theta integration? No? You can solve for it. Okay. Now this is very important model, guys. The next one. Actually, the right hand side is also given, but actually only this integration you think. Okay. How to integrate that one? Okay. See, in integration, in many places, you will see this kind of scenario. What is that scenario? I'll tell you. There is some denominator, na? And there is some numerator, and you are integrating. Okay. It may be difficult for you to see that. Okay, it is difficult to integrate this part. But for example, if I change the numerator to some n1 by dx, let's say it is easy to integrate. If I change the numerator to n2, same denominators. Let's say this also you know how to integrate. And you have observed that whatever this n is there here, it is the combination of n1 and n2. That is some a times n1 plus b times n2 is your n, for example, let's say. Then this integral I is nothing but a times this integral plus b times this integral, right? We are just separating the both integral. So some numerator, if you can say that, if we can write the numerator in terms of some other two different numerators, n1 and n2, then you go ahead and do it such that both integrations you can do. We use this method in so many places. One example is this one. I'll give some more now. Okay. One example is here. Here what you do is, see, if denominator is what here? 9 e power x minus 4 e power minus x. Now in the numerator, if there was 9 e power x minus 4 e power minus x, can you solve this integration? Very easy. What is there, sir? One only, na? Yeah, you can solve. Basically, the point is, can you solve this integration? Yes, we can solve. Okay. Okay. Now, for example, let's say if I ask you in numerator, if derivative of denominator is there, that is 9 e power x plus 4 e power minus x. Can we solve this integration? Yes. Because integral f dash of x by f of x. If you have the derivative in the numerator, then it is simply ln of mod f of x, na, integration. Okay. We can solve both of them. Now, if you see, this numerator here can actually be written as a linear combination of these two. Let us see how. Okay. Because the only two terms are involved, na? E power x, e power minus x. So let us write here 4 e power x plus 6 e power minus x can be written as a times 9 e power x minus 4 e power minus x plus b times 9 e power x plus 4 e power minus x. Okay. So now this is 9a plus 9b times e power x plus minus 4a plus 4b times e power minus x. If you compare, 9 times a plus b must be equals to 4, and 4 times minus a plus b must be equals to 6. So you will get the values of a and b, no? So your integration overall, your I can be written as a times the first integral 9 e power x minus 4 e power minus x by 9 e power x minus plus 4 e power, sorry, minus plus b times integral 9 e power x plus 4 e power minus x by 9 e power x minus 4 e power minus x dx. Done, no? This integral is x only. This integral is ln of denominator. That only is given there. Okay. Now, where do you use it in some other places means, for example, let's say you have integral sin x plus cos x or plus 3 cos x divided by cos x minus sin x is there. Now what you do is sin x plus 3 cos x. Why? Because in the denominator, what is there? Cos x minus sin x. Now in the numerator, if there was cos x minus sin x, very good. We can solve this integration, correct? If in the numerator, if we had minus sin x minus cos x, then also we could have solved this integration. Because this numerator is derivative of denominator, no? Okay, we could have solved it. So this numerator here, whatever is there here, okay, this we have to write as a combination of this as well as this. Can we do it? Yes, we can, because sin x plus 3 cos x can be written as some a times cos x minus sin x plus some b times minus sin x minus cos x. You can do this, no? You can find a and b. Then both integrals. So your integration I will be a times I1 plus b times I2. Okay. Fine. Let us see the next one. This is very important model, guys. See, normally you have seen square root. Square roots only normally, like standard methods. All these things, root ax square plus bx plus c, how to solve. In boards and all, you will have all these questions. How to integrate this one. Okay. Now, but power 2 by 3, you will see some many weird powers also. Now here you see 7 by 2. Here you see 1 by 4. Okay. All these are similar model questions. All are. Okay. So whenever you have this weird powers, this is very, very important question, because you just go through previous mains and see last 2-3 years, like this many questions are coming. Okay. Very, very important, guys. Okay. Idea I will tell you for this one. First, you see whether you can take some substitution or not. Okay. Directly. Direct any substitution is there? Not there, no? Like matlab, here x cube is there. So here x square is there means then we can take x cube as t. X square means we need to multiply and divide by x square. Even if you take x cube as t, here x power 4 is coming. So we can't take that substitution. First, see if there is any substitution which you can make directly. Okay. Now, the important part is this one. Now, this inside some big term is there, na? Power is 2 by 3. Now, here x square is there. So, what you do is the remaining parts you write like this, x power minus 2. Now, here what is there? X cube minus 1. Now, this is the trick, guys. Now, something you need to take common. Every time what you do is, in every questions like this, you will take something common from the denominator. Here, 2 terms are there. If you take one common outside, nothing is going to change. So take x cube common. Then what will happen? If you take x cube common, x power minus 2 dx divided by x cube means outside x square will come because power is 2 by 3. 1 minus x power minus 3 power 2 by 3. So this will be integral x power minus 4 dx divided by 1 minus x power minus 3 power 2 by 3. Correct? Now you can observe directly. 1 minus x power minus 3, you can take it as t. Then if you differentiate 3 times x power minus 4 dx will be dt. So x power minus 4 dx will be what here? Dt by 3. So your integration will be integral dt by 3 divided by t power 2 by 3. Done. 1 by 3 times integral t power minus 2 by 3 dt. Done. Next question. Next question is anyway, square root is there. Whenever square root is there, some standard form it will get converted into. Now this is not complicated. Why? Because you can see integral x power 7 by 2 is there. Now x power 7 by 2 dx you will get if you differentiate x power 9 by 2, you get x power 7 by 2. So if I take t, then 9 by 2 times x power 7 by 2 dx will be dt. That we know. Now see whether denominator can be written as x power 9 by 2. Yes, x power 9 by 2 whole square plus 1 only. Na? So if that is t, then this will be 2 by 9 times dt by root t square plus 1. Now you know how to, what is this basic integral only, na? ln t plus. But you see this one, again it is some complicated powers are there. Okay, what you have to do again, as I told, x power minus 5. First you bring the power to the numerator and remaining you write as it is first. Okay. Next, take either x power 4 or x common. Now, just by logic, see what you do is, normally if there are more terms, then you try for every term. Okay. But here, if you actually see, x power 4, taking x power 4 outside is more intuitive now, because x power 4 power 1 by 4, easy powers will come. So if you take x power 4 common, outside x will come. Sorry. Yeah, x will come. Already x power minus 5 is there. And what will be there here? 1 minus x power minus 3 power 1 by 4 dx. So what will this integral convert to? 1 minus x power minus 3 power 1 by 4 into x power minus 4 dx. Now take this 1 minus x power minus 3 as t. So differentiate 3 times x power minus 4 dx will be dt. So this will be dt only. So your integration will be integral 1 minus, sorry, this whole thing is t we have taken. Na? So t power 1 by 4 dt by 3. 1 by 3 will come out. That's all. No? Okay. Next, this one. Everyone see this question? Evaluate cos root x. They have given. Okay. Now, 1 second, guys. Sorry, one message I was getting. I'll just see if there are any doubts. Okay. Now the method which you already are familiar, it is called by parts. Okay. Integration by parts. Okay. So let me just give, I don't know, shortcut, or it's the same thing. Okay. But just written in easier form. So how I would say that is, see, if you have integration x square sine x, for example, now there are two functions which are there. Okay. Normally one function for differentiation you will put, one function for integration. Now which one for differentiation? Whichever function you feel that it will reduce. Now if you differentiate x square, it will reduce, not 2x and 2. If you integrate it, it will just go. So you will have some method to identify which one for integration, which one for differentiation. ILATE is also there. Okay. So what you do is write D for differentiation, I for integration. Which function will differentiate here? X square. Integration, which function I will do? Sin x. Now keep differentiating this one, 2x. Integration of sin x minus cos x. Again, differentiate 2x, 2. Integrate minus cos x minus sin x. So you may be wondering, sir, when I should stop this process? You have to stop this process whenever this horizontal product is there. Na? This product you can integrate. Whenever you can integrate that product, you stop the process. Here 2 minus 2 sin x, we can integrate. Na? So stop it. Now what you do is draw like this. And at last horizontal line. And start with plus, plus, minus, plus. That's all. Now you have two different types of lines here. One is inclined lines, one is horizontal line. Final one will be horizontal line. Now whichever inclined lines are there, directly you multiply. So x square into minus cos x. And here minus is there. Minus of 2x into minus sin x. It will be plus 2x sin x. And finally a horizontal line. Whenever horizontal line is there, you multiply them, you will get minus 2 sin x. But you integrate it. Last step, you integrate. Okay, that final line, whichever is there, you integrate. That's all. That is only your by parts rule. Okay, minus x square cos x plus 2x sin x minus, what is sin x integration? Minus cos x. No? So it will be plus 2 cos x plus c. This will be the integral value of x square sin x. Okay, so let me just give you one more example. Okay, just one last example. Integral x cube e power minus x is there, let's say. Now this also by parts. One for derivative, one for integration you will keep. No? So for derivative, which function you will keep? X cube. For integration, e power minus x. Keep differentiating. 3x square. Integration minus e power minus x. Now you see whether this product, can you evaluate the integration? No. X square into e power minus x we can't find. No? Again you have to do by parts only. So continue. 6x here, e power minus x. Say x into e power minus x, we can't do integration. So continue. 6 minus e power minus x. This product 6 e power minus x, can we integrate? Yes. So stop. Okay. Now just connect starting from here. Okay. Cross lines. And final one is horizontal line. Okay. Now do plus minus, whatever is there. Now with the inclined lines, what you will do? You will write the result as it is. Just you will multiply those two. So x cube into e power minus x, first one. Okay. So what do we get? Minus x cube e power minus x. Next, this one. So if you multiply, what do we get? Minus of 3x square into e power minus x. Next plus sign is there, but in product minus will come minus 6x e power minus x. And last horizontal line, whichever is there, that is simply minus into minus is plus 6 e power minus x. But last one you will integrate. Okay. So what do we get if you know this answer? So e power minus x integration is minus e power minus x. Like that. Okay. Now, when it comes to this question, simple, what you do is take x equals to t square. Your dx will be what here? 2t dt. So your integration I will be integral cos of root t square cos t. Dx will be simply what here? 2t dt. So 2 times integral t into cos t dt. Correct? Now again by parts. One for differentiation, one for integration. Which one for differentiation? T. Integration cos t. Derivative of t 1. Integration of cos t sin t. Enough. Plus minus. So it will be just multiply the direct t into sin t minus integral sin t dt. That's all. You'll get the answer. No? Okay. Next. Yeah. The next one is very important form. That is integral e power x into f of x plus f dash of x dx. Whenever you have integration in this form, we write it as e power x into f of x plus c, the answer. Because if you differentiate this, you will get this function. Okay. Now let us see this one. Integral e power x into some other function is there. Okay. So like for example, e power x into x, here e power minus x into x cube is there. But there we are not trying to apply f plus f dash, because we know that by parts if I do, I will get the answer. Okay. But there will be some things here. If you start doing by parts, very complicated, differentiating this or integrating it. Okay. So try to write this whatever function which is multiplied as f plus f dash. Now the procedure is simple. What you do is every time, now this is 1 minus x whole square by 1 plus x square. Now the question will be designed in such a way that you will get f plus f dash form. So you write like this, e power x into, now what is 1 minus x whole square? 1 plus x square minus 2x by 1 plus x square whole square dx. Now I will separate this and this. Why? Because you see what happens? You'll get 1 by 1 plus x square, and remaining one will be minus 2x by 1 plus x square whole square. Now, if you actually observe, if this is the function f, this is its derivative only. Okay. So what will be the answer finally? E power x into f of x by 1 plus x square dx. Sorry, plus c. Whenever you have integration of the form f plus f dash, this is what you need to do. Okay. So on that, some questions are there. Just go through it. Now, yeah. See this question, this previous JEE question. Very simple. Okay. Now, this is by parts. We'll do it. Okay. Now, this integration they are asking. And what they have given? They have given the integration of f of x as some psi of x. Okay. So that symbol is called psi. Okay. Like this it is there. No? Okay. Now, this integral x power 5 f of x cube dx is there. Now, what we'll do is first obvious x cube you take t. Then 3x square dx will be dt. So integral x power 5 is there, na? X cube into x square into f of x cube dx, like this we can write. Now integral, what is x cube t? X square dx will be nothing but dt by 3 f of t. Now does it look like something like by parts we have to do? Integral t times f of t dt. One for derivative, one for integration. Which one for derivative? T integration f of t. T derivative is 1. Integration of f of t already they have given. What is it? F of x integration is psi of x. F of t integration will be psi of t. So plus minus. So finally the answer will be, I will be t times psi of t minus integral psi of t dt. The last one. And just back substitute. What is t we have taken? X cube. No? So just substitute, back substitute. So finally it will be x cube psi of x cube minus integral psi of, what is t we have taken? X cube. And dt means, what will be dt? 3x square dx. No? So 3x square dx. Now you can match which option is correct. X cube psi of x cube minus, and yeah, we are forgetting 1 by 3 outside. So 1 by 3 will be there throughout. Okay. 1 by 3 times x cube psi of x cube minus 3 times integral x square times. So I think the first option, no? Yeah. So not the first option. 1 by 3 will not be there for second, because 3 will get cancelled, no? Yeah. Okay. Next, let us see some definite integration also. Definite integration, you all know, the very most important rule is integral a to b f of x dx. Now this integration, wherever there is x, you can replace it by a plus b minus x. not in dx. In the function, wherever there is x, you can replace it by upper limit plus lower limit minus x. The integration value will not change. Okay. Integral 1 to 2 f of x dx is there. You can write it as integral 1 to 2. What is a plus b? 3. F of 3 minus x dx. You can write it like that. Okay. So every time you do that, some kind of change will happen in the integration, and by doing some kind of manipulation we can solve it. Okay, let us just, I will give this one example. This will be there in your CBSE textbook also. Now since if this is I, now instead of x, what we can replace? A plus b minus x. Instead of x, 9 minus x you can replace. 3 to 6 square root of 9 minus x divided by square root of x plus square root of 9 minus x, it will become. Now you see, if you add both of them, you will get 2i, which is 3 to 6. Denominator is same na, in both, root x plus root 9 minus x. What happens if you add numerator? Root x plus root 9 minus x dx. Now which will be 1. So integral 3 to 6 dx. So answer will be 6 minus 3, which is 3. So your I will be 3 by 2. Okay. These questions are there. Some questions are there in CBSE textbook. You can actually do that. Okay. You could have already, you should done using this. Okay. So you will take this as I, this also as I, and you add them. You will get the answer 2i. Okay. So now, but sometimes, now the point which I want to say here is, sometimes what happens is, this f of x whatever is there and f of a plus b minus x whatever is there, both will be same. That means even after applying this rule, this will not change, it will remain same. Like, I will take a random example, very small one. Minus 1 to 1 x square dx is there, for example. If you do a plus b minus x, a plus b is 0, 0 minus x. So x can be replaced by minus x. So if you do that, again it is coming x square dx only. Na? Yeah, in this case, we can actually integrate x square. I'm just saying there will be some functions which can't be integrated directly. But if you do this definite integration rule, that is, instead of x, if you replace a plus b minus x, what happens? The function, there won't be any change. You do that 10 times, nothing will change. So those kind of functions, it happens because f of x and f of a plus b minus x both are same. When those two are same, if you do this, then the inside integration, the function will be same. Na? Okay. Now, this part only I want you to okay, just get it. Whenever these two are same, okay, in functions there is a point. If f of x is same as f of a minus x, it means this implies the graph of y equals to f of x is symmetrical about x equals to a by 2. What is the meaning? If you will take the line x equals to a by 2, if the graph of f of x left side is like this, right side will be exact mirror image. Okay. If f of x, you can take one example like sin x, you take sin x and sin pi minus x, both are same because sin pi minus theta is same as sin theta. Now, if you see, sin x graph is symmetrical about x equals to a by 2, that is pi by 2. You see, sin x graph is like this. What is x equals to pi by 2? This line only, na? It is symmetrical or not? Left side and right side, mirror images. Okay. So, whenever this point, I just want to highlight it. If f of x and f of a minus x, like that. Okay. So, what do we understand? F of x and f of a plus b minus x are same. It means the graph is symmetrical about x equals to a plus b by 2. So on the graph, this is your x equals to a plus b by 2, let's say. Yeah? Then your f of x graph will be symmetrical about it. And what is a plus b by 2? It is midpoint of a and b. Okay. So will you be convinced if I say that the area under the graph from A to B will be twice the area under the graph from A to A plus B by 2 or A plus B by 2 to B. Correct? Because symmetric, na? So can I say that, so in this case, can I say that your integral, so that means if f of x is equals to f of a plus b minus x, how will you identify if f of x and f of a plus b minus x are same? By doing this rule, your function is not changing. If by doing this rule, a plus b minus x rule, if the inside function is not changing, that means f of x and f of a plus b minus x are same. That is the meaning. Okay. So then what to do is, your integration, you will write it like this: 2 times. What is integral a to b f of x dx? Area under the graph from a to b. Na? So if this happens, then it is twice the area from a to a plus b by 2. Or you can write it as twice the area from a plus b by 2 to b. That's it. Okay. Like this. Okay, guys. So let me just see here. Now, this question, if I actually see, it is pretty okay. First, a plus b minus x, let us do. That means x I will replace by minus x. Correct? A plus b is 0. Na? A plus b minus x is 0 minus x. Correct? X you can replace it by minus x. So what will you get? Minus 2x. Now plus 2x sine x. Because when you replace x by minus x, sine of minus x will be minus sine x. So just that is on simplification. Why to bother? You know how to do it. So when you replace x by minus x, this is what you get. Now you add both of them. Correct? That is how you use a plus b minus x rule. Na? Okay, I will add both of them. I will get 2I equals to integral minus pi to pi 2x sine x, sorry, 4x sine x. Because there 2x sine x, here 2x sine x. Na? So 4x sine x by 1 plus cos square x dx. Very good. Okay, now you do a plus b minus x again. That means replace x by minus x. You see what you will get. You will get exactly the same thing. There is no change. You see, it is same, na? So that means when you are applying this a plus b minus x rule, there is no change. It means you can say that the graph of this function, this whole function, is symmetrical about the midpoint of minus pi and pi. What is the midpoint of minus pi and pi? 0. A plus b by 2. 0. Minus pi plus pi by 2. So it is graph is symmetrical about 0. So the area of the graph, area under this graph from minus pi to pi can be written as 2 times area from 0 to pi. Or you can write from minus pi to 0 also, your wish. Okay. So then you write 4x sine x by 1 plus cos square x. Now you see. Now this was the crucial step. This step. 2 times writing. Because now if you do a plus b minus x again, you will get 4 times pi minus x. Sine pi minus x is sine x only by 1 plus cos square x dx. Now if you add, you will get simplified. Because when you add both of them, 4x sine x will get cancelled. So you will get very easy one. So you simply see, if you add these two, what you will get? Minus 4x sine x will get cancelled. 4a will be 2 times integral. What will be there? 4 pi x. Sorry, 4 pi sine x by 1 plus cos square x from 0 to pi. Now it is simple. Cos x you take t. Then sin x dx will be dt. Now this is t, 1 plus t square. Directly you will get the answer. Okay. Yeah. So this point only I want to say. Okay. Okay. Mainly the point which I want to describe is, by doing a plus b minus x, replacing, sometimes the functions doesn't change inside the integral. Then if you add it with the original one, whatever you do, nothing is going to get simplified. So in that case, what you need to understand is, you need to understand that That is a problem based on symmetry. Okay. And then we are proceeded. Okay. Take a screenshot so that you can revise. Fine. Okay. So let us see. All these are simple examples only. Like this one, integral a plus b minus x example only. Sometimes you need not add. If you do a plus b minus x, na, this is x power n dx. Now directly, if you now the answer is there, x power n minus x power n plus 1 dx. Now you can integrate this, na. Okay. So sometimes if you do a plus b minus x, no need to add with whatever is given. Directly you will get the answer sometimes. Okay. Just for that only I have taken that question. Yeah. Now you see this one. Okay. Let us see. This is I. Now your I can be written as a plus b minus x we can do. That is pi minus x. F of sine pi minus x is sine x only dx. Now add both of them. What you will get? 2i. It will be integral 0 to pi. Now if you add pi times f of sine x dx. Okay. So your I can be written as pi by 2 times integral 0 to pi f of sine x dx. Now you see, is there any option? No. Correct. There is no option. Your so I will be pi by 2 times. There is no option like that. Achha. So is there any mistakes in the step? No. But you see in the options 0 to pi, only two options are there, A and B. A is obviously wrong. Okay, f of cos x we are not getting here. B is also wrong because by 2 is missing. No? Okay. Now in C and D, the limits are up to pi by 2. How 0 to pi would have converted to 0 to pi by 2? I'll tell you. See, now if you do a plus b minus x again, what will you get? That means x you are replacing it by pi minus x. If you do that, this will remain same. Na? That means, it means symmetry. Whenever the function is not changing inside the integral by doing a plus b minus x, it means that function is symmetrical about the midpoint of the limits. That is between 0 to pi by 2. What is it there? 0 to pi, the midpoint is pi by 2. Na? The graph is symmetrical about pi by 2. That is what you need to understand. So the area under the graph from 0 to pi can be written as 0 to pi area can be written as 2 times area from 0 to pi by 2 and f of sine x dx. So 2 gone. So the answer is pi times integral 0 to pi by 2 f of sine x dx. Now if you do a plus b minus x again, you will get 0 to pi by 2 f of cos x dx. Correct? Instead of x, pi by 2 minus x we are replacing. No? So now you see which option is there? D option. No? Yeah. Pi times 0 to pi by 2 f of cos x dx. Okay. Next. Next function is next thing which is there here is on periodicity. Now I'll take some 5 minutes of lectures, okay, on periodicity. Now I am assuming that you all know what is the definition of period of a function. Okay, a function is f of x is there. A function f of x is there. It is said to be periodic if f of x plus t is same as f of x. The function is repeating. Okay. One second, guys. Yeah. So Yeah, a periodic if this is there. Okay. Now on periodicity, there are three basic rules. First rule, integral 0 to n times time period f of x dx. Again, this rule is only applied if f of x is periodic with period t. And here n is integer every time, or m also we will involve sometimes that they are integers. So area under the graph, how to, this is simply n times integral 0 to t f of x dx. Very easy to understand because area under this graph in n cycles is n times area under one cycle. Okay, this is first rule in periodicity. Second rule, integral m times t to n times t f of x dx, or let me just say it like this. If integral a to b is there, f of x dx, again f of x is a function with period t. You can add or subtract time period from both. If you're subtracting time period, then you have to do it from both upper limit and lower limit. If you're adding, you have to do it from both upper limit and lower limit. And you can do this any number of times. When I say any number of times, what I mean is you can write a plus 7t. Then upper limit also 70 you have to add. Okay, any this you can do. That means addition or subtraction. In general, if I talk a plus n times t, b plus n times t, this you can do to the limits. Okay, you can add or subtract multiple of time periods. For example, let's say if you have integral 2 pi by 3 to 37 pi by 3 sin x dx. Now what is the period of sin x? 2 pi. You can subtract 2 pi. What is there? 2 pi by 3 minus 2 pi. And same 2 pi you need to subtract from here. You can do this. If you want, you can add also. Okay. Next. Next one. Third one. Last one, but very important rule. That is, if you have integration from a to b, f of x dx, and this b minus a is multiple of time period, that is upper limit minus lower limit. If it is multiple of time period, for example, let us say integration 7 pi by 3 to 45 pi by 45 pi by 3, can I take? Not 45 pi by 3, just a second guys. 7 if I subtract, it should be multiple of 3, so 46 pi by 3 mod sin x dx is there, for example. Okay, now what is the difference guys? 46 pi by 3 minus 7 pi by 3, 39 pi by 3, which is 13 pi. Now this is multiple of time period of sin x. No? Mod sin x period is what? Pi. I'm not saying sin x, mod sin x. Mod sin x period is pi. Now this difference, upper limit, lower limit difference is what? Multiple of pi only, no? Multiple of time period. Whenever you have this kind of situation, that upper limit minus lower limit is multiple of time period of inside function, then you can start this integration anywhere you want. When I say anywhere you want, you can start from 0, then maintain the difference. What is the difference? N times t, so nt f of x dx. If you want, you can start from 7, then 7 plus nt it must be f of x dx. That's all. You maintain the difference, and this you can only do if the difference is multiple of time period. If the difference is not multiple of time period, I will maintain the difference, sir, means no. Like integration 1 to 3 is there. You can't write like 2 to 4. No. Yeah, you can do that if the difference whichever is coming here, that is 2. If 2 is the multiple of time period of the function which is there inside, if 2 is multiple of the time period, then you can do, otherwise not. Okay. That's all. These three golden rules, guys. Okay. What are those three golden rules? 0 to nt f of x dx is n times 0 to t. area under the function in under n cycles is n times area under one cycle. First rule. Second rule, you can add or subtract time periods for both upper limit and lower limit, any number of times. Third rule, if the difference of upper limit and lower limit is multiple of time period, okay, then you can start from any lower limit, but make sure the difference is maintained. Okay, if the difference is multiple of time period of that function. Let us come to this question here. Integral f of x is given, f of x plus pi they are same. Okay, now what will be f of x plus pi here? F of x plus pi will be, now you see here in this question, if f of x is there, here x will be there, limit, upper limit. X plus pi means upper limit will be x plus pi, no? So integral 0 to x plus pi, what is there inside? Cos square t dt. Okay, cos square t dt. Now this is nothing but a function with period pi. This period of cos square t is pi, na? Now what they are asking, that is equals to, okay, in terms of f of x they want us to write, na? That means from 0 to x. Okay, let us see. Can I write this as integral 0 to x cos square t dt plus x to x plus pi cos square t dt? Okay, now the first one is nothing but f of x only. Second one, you see the difference of upper limit and lower limit. What is it? Pi, na? And pi is the multiple of time period. That is pi. Pi is the multiple of pi only. Pi into 1 is pi. So whenever the difference is multiple, you can start from any lower limit. Na? You start from 0, it will be up to pi. Okay. Because if I start write like this, then this will be f of pi. Na? Because if f of x is this one, then f of pi will be what? 0 to pi cos square t dt. So the answer will be f of x plus f of pi. Okay. A. Fine. Okay. Yeah, I think the time is over. I think 7:45. No? Yeah. Okay, guys. So we'll stop the lecture here. Okay.